Right, and today in Algebra 2, we're going to look at section 11.3. We're going to split this up in 2 days. So today we're going to look at the first half. This talks about data distributions. We should be able to evaluate data distributions at the end of this lesson. So we're going to start out with this first one. Nia and Nash were asked to estimate the mean and median of the following data set. Nia said the middle value is 11. Remember that median is the middle. Both the mean and median are approximately 11. That's what Nia says. Nash says most of the data are to the left. I think the mean and median will be about 9, with the mean slightly larger. It asked, is either Nia or Nash correct, and explain why. Okay, so if we look at the data, again, we see that most of the data is to the left, so Nash was correct on that. Right? The median in the middle, approximately 11, is what Nia said, okay? But we see that we have more of our data on the left-hand side. So Nash says that the mean and median is going to be about 9. So Nash is correct. Because most of the data is close to 9. But there are large number of values that are greater than 9. Therefore, the mean, which again, remember, means average, will be a little larger than 1. It says, what strategies could you use to approximate the exact mean and median? So to find the median, we would write all the data out and find the median, which again, remember, is just the number in the middle. And then we would average all the numbers to find the mean. And then part C, which measure of center is more representative in this case, the mean or the median, okay, and explain. We look at, we have a lot of the data is being stretched out to the right, and so the median is going to be more representative because the mean is affected by more data being stretched out to the right. So now we're going to take a little bit more in-depth look at all of that. Let's start out with some definitions. The standard deviation is a measure of how much the values in a data set vary or deviate from the mean. So how far away they are from the mean or the average. It is the measure of the variability or spread out of the data. The notation for mean is an X with a bar above it. The notation for standard deviation is the Greek letter sigma. So again, this is the Greek letter known as sigma. In order to find the standard deviation, we need technology to do that. So I have included instructions for how to do that on both the TI-30 X2S and the TI-30XA. So these are those those instructions for doing that. And then on the back, I've also included instructions for how to do this on the graphing calculator. We will be doing this in class. I will be showing you the graphing calculator and the TI scientific calculators in class. Okay? So these next examples are using the calculators. So it says, what are the mean and standard deviation of the following data set? Again, we're using the calculator here. So we're going to put all of this data into our list area in the graphing calculator. And then we're going to follow the steps above to calculate, have our calculator calculate this for us. So our mean, which again is the X with the bar above it, is equal to 11.625. Our standard deviation, and we're going to use the one of the population, okay? Because our calculators will give us a standard deviation for the population and also for the sample. But we want the standard deviation of the entire thing here, which is our population. So our standard deviation is approximately 6.313. Right, so number 2, it's asking me what is the 5-number summary of the data set from number 1. The 5-number summary includes the minimum, the maximum, the median, the first and third quartile. Remember, first and third quartiles come from box and whisker plots. Okay, so the very first thing you want to do is put them in order. So put data in order first. So when we do that, we have 3, 4, 4, 6, 6, 7, 9, 12, 13, 13, 14, 15, 16, 17, 22, and 25. The minimum, that's going to be easy to see. Our minimum is 3. Our maximum is 25. Remember that if they had asked me to find the range, okay, the range, I just subtract the minimum from the maximum. The median, that's the number in the middle. Okay, so count how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's an even number, so I go to 8 from both directions. So 1, 2, 3, 4, 5, 6, 7, 8 gets me 12. Coming in 8 from the other direction gets me 13. So I find the average of those. 12 plus 13 cut in half. The median is 12.5. So now I want to find my first quartile. Remember box and whisker plot. So we'll go ahead and draw a box and whisker plot. I need my number line. I'm going to do 12, 13, all the way out here is 25, all the way out here is 3. Remember, in a box and whisker plot, the middle of my box is the median of the whole set, so that's going to be right here. Then the first quartile, that is the median of the first set or the lower set. So from 1 to that 12, so I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So count 4 in, so 1, 2, 3, 4, and then 4 the other way, I get 6 plus 6, cut in half, is still going to give me 6. So my first quartile is 6, so 3, 4, 5, 6. Okay? So that's where my first box ends. So now I want the third quartile. So now I do the same thing with my upper set. Okay. So again, I'm going to count in 6. Okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So count in 4 numbers. 1, 2, 3, 4 gets me 15. 1, 2, 3, 4, 16. So 15 plus 16 cut in half is 15.5. So 13, 14, 15. So about right here is where my second box ends. So remember box and whisker, I draw out my whiskers out to my max and my mins. Okay. Right. Number 3, list the mean, standard deviation, and 5-number set, or sorry, 5-number summary of the following data sets. And I'm going to plug all that in my calculator, and my calculator is going to give me the mean, the average, is 20.73. My calculator is also going to give me the standard deviation, which is 11.3. Then I'm going to find the median, the min, the max. These numbers are already in order, so that's nice. So I see my minimum is 3, my maximum is 35. The number in the middle, so again, count how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have an odd number, so I know I'm not going to have to divide by anything. So if I count in, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my number in the middle. My median, oh, not 8, sorry. My median is 19. so now I do the first quartile and the second quartile. So I'm looking at from the 19 below. I come in and I have 1, 2, 3, 4, going the other direction, 1, 2, 3, 4, both 12. So the first quartile is a 12. Coming in the other direction, starting at my 25, okay, 1, 2, 3, 4, 1, 2, 3, 4, I'm at a 33. All right. So now it tells me to compare the different types of distributions. We're going to look at the shape, the center, and the spread of the distributions. The standard deviation, the range, and the interquartile range are the three measures of spread. Okay, so we need to know that. Standard deviation, range, interquartile range. Those are my three measures of spread. The range of data is the difference between the maximum and minimum. The interquartile range is the difference between the third and first quartile. When measuring center and spread, median and interquartile range are used together, and mean and standard deviation are used together. We need to talk about skewed distribution. A skewed distribution is one with a shape that is stretched out either in the positive or negative direction. Symmetrical distribution has a shape that when reflected across the mean, the display is roughly the same. The mean, median, and the mode are all about the same in a symmetric distribution. You can use the mean and standard deviation to describe the center and the spread when it's normal. So we're going to look at that. So skewed left in the negative direction, okay? So my bigger values are all here to the left, right? My curve goes to the right. Symmetric here in the middle, it looks the same. Skewed to the right, okay, means I'm going in the positive direction, so my bigger values are going to be out here on the positive side, but my mode, my median, and all of that is more to the left, okay? The median and interquartile, so median and interquartile range are less affected by skewed data, therefore better representations of skewed data. So if I have data that is skewed, I'm going to use my median and my interquartile range. If I have data that is symmetric, I'm going to use the mean and the standard deviation. All right, so we're going to practice that. What measures of center and spread would you use for the following data set? Okay, so we want to make a histogram, or just a fancy word for a bar graph, of all of this data. Okay, so let's see. I've got 10 all the way up to 37. So I'm going to use like, we'll start out here at 10. And so 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 28, 29, 30, 35, 37 is going to be a little bit off my graph. I'm going to make this a frequency of 1, 2, 3, 4, and 5. The number 10 only appears once. So there's my 10. 13, okay, so here appears once. 16 appears once. 21, 22, once. 26, once. 29 I have twice. 30 I have once. 33 I have 3 of those. 35 once, and then my 37 is also going to be there. So I notice, like if I were to draw this, this is skewed left. Therefore, my median and interquartile range are going to be the best measures of center and spread. Okay, so let's go ahead and find our median, and that's the number in the middle. When we work that out, okay, we find that our number in the middle is 29. So then my first quartile, remember that is my median of my first quartile below my median. When we work that out, we find that it's 21. Our third quartile, again, the median from our numbers bigger than our median is 33. So now my interquartile range, subtract those two. 33 minus 21 gets me 12. So my interquartile range is 12. My median was 29. Let's do some more of those. So here, what are the better measures of center and spread? I see I go from 55 to 61. So 55, 56, 57, 58, 59, 60, 61. And I'm going to make this 1, this 2, this 3, this 4. 55, I have 2 of them. So 57, I have 3 of those. 58, I have 2. 59, I have 3. 61, I have 2. I draw this. It looks like it's normal, so this is not skewed. So this is going to be my mean and standard deviation. I can find that by plugging these into my calculator like we were doing. So my mean is equal to 58. My standard deviation, again, of the population, 1.87. All right, we're going to look at one more of those today, and that's where we're going to stop. So here, I go from 110 to 190. Okay, so I'm just going to go and start here is at 100. So this is 110, 20, 30, 40, 50, 60, 70, 80, and this would be 190. And this is 1, 2, 3, 4 times. 110 appears 3 times, so my 110 right there. 120 appears twice. 130 appears once. And 40, 50, all the rest of these appear once. So just like that. If I draw my curve, you see that this one is skewed right. So again, we're looking at the median and interquartile range. So if I find my median, I have even numbers or set of numbers. So when I find the middle, I get 130 plus 140 on the average of those. So my median is 135. Now I do my first quartile, the median of the first quartile and the third quartile. So the median of the first quartile, I'm going to have 110 plus 120 cut in half. I get 115. Third quartile, I end up with 160 plus 170 cut in half gets me 165. So my interquartile range, I take 165 minus 115 to get 50. All right, so that's where we're going to stop for today. Our homework today is 11.3 worksheet number 1. It covers all of this, so some of them you'll have to use your calculator, right? You can use either the graphing calculator or your scientific calculator. And then on some of them, you'll also have to draw these little bar graphs to determine what does it look like. Is it skewed left, skewed right, or not skewed at all? And then which measure of center and spread would be the best to measure all of those and discuss that data. Tomorrow we will finish these up.